All right, welcome to MCR Day 6. So this is the last section of Unit 1. The rest of the Day 6 and Day 7 are going to be reviews for your first test. So the very last section is scientific notation, kind of a nicer one, a little bit shorter. So we're first going to figure out how to go from what we called standard notation to scientific notation, and then back and forth. So for scientific notation, say I have a number like 61,000, that'd be standard notation. For scientific notation, it always has one number, just one integer in front of the decimal, and then you put as many numbers after until you get to all zeros. So I would do 6.1. So you have this integer. It's got to be a non-zero, and it can only be between 1 and 9, essentially. And then we put our decimal, put our number, and then you write it to a power of 10, where again, that power needs to also be an integer, and that represents the number of units you moved it. So I moved the decimal. It was here, 1, 2, 3, 4. So to put 61,000 in scientific notation would be 6.1 times 10 to the 4th power. Other examples of scientific notation would be maybe it's 7.253. You just don't put the remaining zeros, but you can have zeros in the middle. So it could be 8.0124 times 10 to the 5th. And these are just easy ways to write really large numbers so that they're easier for us to comprehend. So on that note, if you have a negative exponent, what it does is it's actually saying that it's 1 divided by that number. So if I have x to the negative 3, that's really 1 over x cubed. So if you have negative exponents, kind of think of it as you're making it smaller. If I had 2 to the negative 3, then that would be 1 over 2 cubed, or 1/8. And if you write that as a decimal, it's a lot smaller than a 2. So it's a way to make your smaller numbers or your fractional numbers. So when we're working on these powers of 10s, the piece right here, you can either have a positive exponent, which means you're multiplying by powers of 10, giving you a larger number, or you can have a negative exponent, which essentially means you're dividing this piece. So you're going to get a smaller number. So if you just had regular 2 times 10 cubed, think of that as 2 times 10 3 times. So you're going to get a much bigger number, 1, 2, 3, or moving the decimal 3 places. But if you have 2 times 10 to the negative 3, that's like 2 times 1 over 10 cubed, or dividing by 10 3 times. That's how you get the 0.002. So it makes it a lot smaller. So keep in mind what they do. If it's positive, it means you're going to get a bigger number. If it's smaller or negative, you're going to get a smaller number. So kind of thinking, when would I use a positive exponent? When would I use a negative exponent? So when we want to actually write the number in scientific notation, you move the decimal wherever it is, either smaller or bigger, until you have only one number in front of the decimal point. So just one digit. So 2.136, 9.052, you move it to just have one number. And then you count the number of places you move the decimal point, and that's going to be your n. So what do I mean by that? If it was 2136, the decimal was right here. I moved it 1, 2, 3, and would be 3 to get my 2.136. If the number was 0.009052, this one right here, I moved it 1, 2, 3. So n is still 3, but in this case, because I started with a small number and turned it into a larger number, it's going to be negative. But for this first one, I started with a big number and made it smaller, so n is going to be positive. So it just depends what you started with. In general, if you started with a number between 0 and 1, it's going to have a negative exponent. If it was bigger, it's going to have a positive exponent. So again, positive exponents are like multiplying, so the number gets bigger. Negative exponents are like dividing, so the number would get smaller. Then how you finish is you write your answer in scientific notation. It's going to be some number times 10 to whatever your n was. And then if it helps, check your answer mentally. So if you get down there and you say it's 9.052 times 10 to the 3, that's going to give you a bigger number. Is that what you wanted? So just check that answer mentally. All right, so go through those steps a couple of times if you need to read them over. And then try a couple practice problems. So at this point, go ahead and pause the video and try a few of these. So hopefully you have paused, you have tried, and you are back. So this is a very large number. So very large numbers are going to have positive exponents. This is a small number, meaning between 0 and 1. So that's going to have a negative exponent. So to go through these, I want to get to where I only have one number in front of the decimal. Then I'm going to write all of the non-zero numbers until I get to all zeros. So this is just going to be 2.95. And then I'm going to count how many decimals I moved it. So it was at the end. So I moved it 3, 6, 7, 8. So it's going to be times 10 to the 8. Then for this one, I'm going to move it until I have just one number in front of the decimal. So that's 1, 2, 3, 4. And because it's a smaller number, it's going to be a negative. This one, I'm going to move until it's 6.4. And then I move the decimal 1, 2, 3, 4 spots. And then over here, again, think, is it going to be negative or positive? It's going to be negative because it's a really small number that I'm making bigger. So I'm going to move that decimal 1, 2, 3, 4, 5, 6 to be 1.8. And then times 10 to the negative 6. And then finally, this one, I'm only moving 1. So it's 7.5 times 10 to the negative 1. And then just make sure when you're done, you always want to check your work. Does it make sense? If you're going back and forth, did we go the right way?